All right, welcome everybody. I think we're good to start here. Um, yeah, here we go. So welcome everybody. We'll continue our discussion with systems of equations here shortly. I'll go over the addition/elimination method, which is really just the same thing that goes by two different names depending on what book you're using. First, I wanted to just point something out here. So here I'm just on the front of the Ventura College webpage. So very front of the webpage. So one of the links that you want to be able to find on the Ventura College webpage is where the calendars are. So there's a couple reasons for this. So if we go into calendars, and they keep moving the web page around. So even me as the professor, I have to keep finding where they put this, because it seems like at least once a year they want to redo the web page, so they reorganize all the links. But if you go to academic programs, and then you can't quite, well, let's see if I can move this without it jumping. Is it going to jump? If you go to where was I? Academic programs. So over here it says academic calendar. If you click that, it takes you to a spot that has some good stuff. Maybe I need to shrink this window. Not helping much. But if you go down, you see they finally have the fall 2021 final exam schedule. So that hasn't been up. Usually they get that out before the semester starts. And in fact, we're supposed to have final exam times in our syllabus, but the syllabus came out, 4 weeks ago, and they're just getting the final exam schedule out now. So if you want to see when your final exams are, you just click on here, and then you'll know when that final exam is. Also, there's the instructional calendar. We have reason to talk about both today. So I'm going to point both of these out. So 2021 instructional calendar, fall 2021 final exam schedule, right? And you all just saw how I did that. So if you need these forms, you can just come back and check them anytime you want. They're posted on the Ventura College webpage. And the forms I'm about to show you are not just for my class. They're for every class on campus, okay? So the instructional calendar, let's see, where are we? All right, there. So fall 2021, it is what, September 13th? So we are in week 5. Okay, so we're in week 5. And so what that means is, remember I mentioned you'd have a test about halfway through the semester. So that's around week 8. So that's about 3 weeks from now. Now, I don't know the exact date because what I don't want to do is give you a test right in the middle of like a section or something. But we'll talk about that as the date approaches. As we get into like week 7, I'll be able to give you a little bit more info. But just be aware, there's a test coming up in the next few weeks. So you go, okay, so what should I do with that information? The key is to be as caught up as you can, right? Some of you are saying, every time a new assignment comes out, I'm going to work on it as soon as I can. I'm going to try to do what I can. That's great. Other people are going, I got time. I'll wait. I'm going to wait. I can still wait some more. And then all of a sudden the test comes up and you're trying to learn all this stuff at the last minute and the brain doesn't work that way. So basically get caught up. If you have fallen behind or you're starting to develop some lazy habits, get caught up now. So it's not going to be any issue for you when all of a sudden you realize that test is 2 weeks out or a week out or 5 days out or a day out. And you can work on it, all right? And as we approach, I'll go over, I think I talked about it before, but the whole practice test and exam and retake for the first exam and that kind of stuff. So we'll go over all of that. But the thing that you can do to be best prepared is just get as much of the homework done as you can. If you have sections that you were confused about or not quite caught up on, look over those even outside the homework, right? Find ways to study that stuff. The more comfortable you are going into that test, and especially the week of the test, the easier that whole process is going to be for you, the better your grade will end up being. So that's my recommendation. Start work on getting caught up now. Even if you've fallen a little bit behind, if you just speed up your pace a little bit so that you're caught up 3 weeks from now, that's not that hard, right? What's hard is when all of a sudden you're 8 assignments behind and you need to get caught up by next week. All of a sudden, that's pretty hard to do, and a lot of times it means students don't end up finishing the class, okay? So just a heads up on that to give you an idea. Somewhere around somewhere in the first half of October, you can expect to probably have an exam somewhere around in that first half of October. I'll give you more specific date as we get closer, but it kind of depends how we're moving through the material, right? I don't want to force you to take a test at a time when it means scores are going to be lower, right? I'm going to try to pick the time that I think is going to work for most people and that they'll do well on. Okay, so there's that. Where am I? Right, so that's that one. That's that calendar, right? And let's see, this is a Monday, Wednesday class, so none of this other stuff matters. Oh, and then you can see, remember, we knew this before. We knew when finals week was, but we didn't know when the actual finals were. So other piece of information that's good to have, here's the actual final exam schedule, fall 2021. So the way you read this is that the columns are days of the week in December, and the rows are time slots, okay? I am required to have something due at the time of the final. Guess what it's going to be? It's going to be your final exam. You will have an opportunity to complete the final exam early if you like, but I cannot have you complete it any later than that final exam slot, right? If you do that, then we have to get into paperwork and all sorts of stuff because then what happens is students can say, well, he let that one student complete it late, but he didn't let me complete it late. What's going on? And that's fair. That would be a fair criticism, right? So we can't do that kind of stuff. In order to make sure that we're treating all students fairly and, that all students are getting, being treated with the same opportunity to do well in the class, then we have to cut it off at the end of that due date or at the time slot. The only reason that I could extend beyond that is I think it's happened twice maybe in my 8 years at the college, and that was because students were in the hospital, and so they ended up taking an incomplete, which then can become a problem because sometimes students, even when they're doing well, take an incomplete and they just sort of forget and never finish the class. So that can be an issue. So just make sure you don't want to go that route. Oh, by the way, at the end of the semester, I always get students asking me for incompletes. You can't just get an incomplete because you're failing the course and don't want an F. You have to have some kind of like legitimate medical reason or, some kind of really good reason why you wouldn't be able to complete the course. But also, you're supposed to be in good standing at that time. So if you have a failing grade in a class, you can't get an incomplete, right? You have to be passing and then go, well, I'm passing, but also I can't come to the final because I'm in the hospital having surgery. And you go, oh, okay, yeah, that meets an incomplete, right? So let's see, what are we? We are, let's see, we're a Monday, Wednesday class that meets at 10. So Monday, Wednesday at 10. So I'm looking for it to say MW10. Here we go. Looks like it's this one right here. Monday, Wednesday at 10, right? That's when I'm in that class right now. Okay, Monday, Wednesday at 10. So that's going to happen on the very last day of finals. So don't book well, I guess since we're online, you can do what you need to do as long as you can get your work done. But sometimes when we're on ground, students miss the final because they booked like a cruise or vacation or something, but like, a day before the final, which is a problem. So that means 10:15 to 12:15 p.m. That's when your final is going to be due, just so you know now. That's when that final will be due. If you turn it in at 12:16 p.m., it will not be accepted. You have to turn it in before 12:15 p.m. on that day. Make sure you know your AM and PMs. I've had some students get confused and turn it in at the wrong time, and that causes some problems. So make sure you know AMs and PMs and when the dates change and stuff like that. That sounds silly, but it's literally been an issue in the past with some students getting confused about when an assignment was due. So just be aware of that. You can also figure out when all your other final exams are, because this is not just the final exam schedule for me. This is for your all of VC. And we have to follow this, right? I can't just say, you know what, I'm going to change the final to be at this other time instead. I know that some of you have teachers that break the rules. We're not allowed to do that. So I won't be doing that. So this is, you can find your other classes. If you have a Monday, Wednesday at 8, you can find that one and figure out when your final is going to be. And then you can kind of plan that week accordingly. Okay. And it even says down here, student request for early or late examination. Students requesting late exams may obtain a petition from the instructor or division office. Approved petitions are to be filled with the office of the division dean prior to the exam date, no exceptions. The school takes this very seriously because it opens us up for, people can make claims that we're being unprofessional, then we're not treating everyone the same. So what that means is you have to file the petition. Basically, I have to sign it first. So I have to think that you have a legitimate reason to take the test at a different time. Then it goes to the dean. The dean has to agree, and that all has to be done before the test. So like if you miss the test because you overslept or something, well, then that paperwork wasn't filed ahead of time, and then there's no extension, right? So just be aware. Some students don't realize how seriously the school takes those final exam times. They take it very seriously. So okay. So I'm not seeing any questions, so I think we'll go ahead. I just wanted to give you that information. And again, you can get to it right from the front of the Ventura College webpage. And then all that information is available to you. Just part of things you should know as a responsible student as far as organizing things so that you can do them in the best way possible. Okay? Okay, let's see. Let's close that. Make sure let's see all the, let's close that so I don't expose any emails. Right. Okay. So are there any questions before we get into anything? Anybody have a question they want to ask me or a concern or anything like that? No, everybody's good. Okay. Then we've been talking about systems of equations. We talked about systems of equations graphically, which is really great for understanding systems of equations and making sense of them, and then having like a visual. A lot of students sometimes say like, I'm a visual learner, and it's interesting. There's a lot more research going on in that area of learning, and it turns out people aren't really just visual learners and audio learners and stuff like that as much as was thought maybe 15 years ago. But even then, it can be helpful to have some visuals, right? In order to see something visually is a whole lot better than just seeing a page full of, algebra work. Your brain cannot grab information in that same way looking at a bunch of text that it can from looking at a picture. So being able to look at those pictures that we talked about in the systems of equations is very helpful because it'll help you remember what kind of solution that you have, right? So there's a question, did I open more units in Delta Math? I did not. I was sick over the weekend. I'm starting to feel better now, and I'm going to have to go into my 3 office hours on campus today, and that's on my list of things to work on today. So I'll get more work out there for you to work on for those of you who have completed everything. So I'll get that done for you. So the systems of equations graphically is very great for understanding conceptually what's going on. It's not so good for actually solving problems because it's inexact. And if you have your intersection point is not nicely on some grid lines, then your answers become less useful to you graphically. Okay. So then we turn to these methods of solving systems of equations algebraically. So here we have some pros and cons. Solving systems of equations algebraically will work for you every single time, okay? There's a price you pay for that, though. Like, that's nice in mathematics. When we have something that will work for you every time, that's a great tool to have because if your other tools aren't working, you go, I'm going to pull this one out and use it. We're going to have that with factoring. When we solve equations by factoring is the easy way to do it. So you want to first try to solve equations by factoring. Problem is, some equations don't factor. Then you have to pull out the quadratic formula. The quadratic formula is a lot more work, but you know what? It works every single time. So if you're having trouble with the other methods getting a solution, All you got to do is pull out the quadratic formula. It's going to work for you. It's the same thing here with the system of equations. Using substitution and using the method we're going to talk about today, they will work every single time, but they are definitely more work than just throwing a system into, say, a graphing utility like Desmos or something like that. Okay, so we talked about substitution method. We did a few examples last time. If you're, if you missed that or whatever, definitely go watch those videos. But there's endless videos out there on using substitution for your systems of equations. So use those as you see fit, right? You need to know how to do that. Go back and watch those videos if you need to. The second method available to you to solve systems of equations algebraically is what's called addition method or elimination method. They go by different names. It really just matters which textbook you use, whether it's called addition or elimination. There's literally no difference between the two. It's just different names. Like sometimes you know somebody and like a group of people call them one name, and then like you go to their house and their parents call them by a different name or something. It's still the same person. They just have two different names. It's the same thing with this. It's the same exact topic with two different names, addition and elimination. I prefer to call it elimination, but some of you may have used textbooks that called it addition in the past. It doesn't make any difference what we call it. We mean the same thing when we're saying that. Okay, and it's a different method. So why do I need to learn a second method to do something that I already know? You just told us, Professor, you just said that I can use substitution to solve systems of equations every single time. Well, if that's true, then why do I need to learn a second method, right? And that's a good question. The answer is because some problems, when solved using substitution, are going to be a lot more work and are going to be a lot more error prone. You're more likely to make a mistake if you're using substitution, whereas some problems are better using substitution. It just depends on the structure of the problem that you're looking at. Remember, I kind of told you last time, or I did tell you, if you have a systems of equations where one of your coefficients on your variable is a 1 or a negative 1, substitution is probably going to be an easier way to go for that particular problem. Well, then, that kind of leads us into when you would use the elimination method. If none of your variables have a coefficient of 1 or negative 1, probably you want to use elimination, right? It's not true every single time. There are plenty of problems where it's the same amount of work both ways. It's not a huge deal which one you use. But if you use substitution on one where it's not ideal, you end up with a bunch of fractions, and then you're doing a bunch of fraction operations. Most of us would rather just skip it and say, why deal with fractions if I don't have to, right? We're not scared of fractions. Fractions are fine. They don't intimidate us. But also, that doesn't mean I want to do it, right? If there's a different way to do it. That's true in all mathematics. If you're doing things harder than necessary, then you're going to make more mistakes. It makes sense. If you're doing things in a hard way, you're more likely to make a mistake than if you do it in the easy way. So try to do it in the smart way, right? It's the whole work smarter, not harder. Sorry, I got to check this. The campus is emailing me something. Oh, this isn't. It said Ventura County. I thought it was the Ventura County School. This is about I guess my ballot was received. Okay, I voted. Right. Okay. Here we are. So let me extend this. Sign in. Okay. So let's take a look at that. The elimination method. Let's see what we got going on here. Okay, so let's do an example, and then I'll walk through the steps that you would take in order to solve this. So as always, we're solving a systems of equations. Okay, so we're starting off with one that's going to actually not take a ton of steps to do. It's going to be pretty straightforward, but it's just so you get the idea of sort of the philosophy or the theory behind the elimination method. And then once you get it, then we'll get into the harder ones and you go, okay, I see how this works. So looking at this systems of equations right here, we want to solve this. Could you use substitution to solve this systems of equations? Yep, you could. But it would be a problem in that if you take any of these variable terms up here and you try to solve for that, remember that was our step in substitution. Solve for one of the variables in one of your equation. Well, any choice you choose up here for variable to solve for, sorry, my throat's getting kind of dry. I got to get a water. I'll be right back. Okay, sorry about that. My throat was getting dry. It was getting hard to talk. Okay, so we have a systems of equations. Notice if I take any of those variables there and I try to solve for that variable, I will inevitably end up with fractions, right? Like take, for instance, this 5x. If I'm going to solve for this 5x, at some point I'm going to have to divide that equation by 5, and then I'd have a 3/5 and a 2/5 in that equation, which will work mathematically. But now you're dealing with fractions. You're going to do fraction additions and all that kind of stuff. So we'd like to avoid that if we can help it. Let's see. Okay, so then there's a question. I was struggling on writing systems of equations from context and systems of equations context graphically. Yep, we can go over those. We can definitely go over those either later today. Probably won't have time today, but we can go over that next time. I'll make a note of that. I know that's confusing for students, but we can go over that. If I forget, bring it up next time, and we'll pull up a couple of those problems and look at them for sure. Okay, and then there's the question, will we ever cover systems of equations with 3 variables? I can do one real quick. We don't spend a ton of time on that. It's not one of the big emphasis problems, but I'm supposed to make sure that you've seen how to do it. So we could take a look at all of those things. So 3 variables. It's a little bit of a mess to try to show online. I might have a video somewhere that I can post and you guys can take a look at it. But there's lots of good videos out there on how to do that. So I'll take a look about the 3 variables one, and we can definitely do the one about context, because that's where students can have difficulty, because some students are really good at memorizing stuff, and to the point where sometimes students can memorize things without necessarily 100% understanding what that thing means, but you're so used to doing the process that you memorize it. But this is why we have to be very careful as math instructors to make sure that people are getting the material and not just able to do problems. It's because it requires critical thinking and like logic and reason in order to make that transition from the words on the page to an equation on the page. It's a tricky thing, and it's not something where I can just tell you, like here I'm showing you systems of equations, I'm showing you a process, and once you work through the process, you get it, and you go, okay, it's the same thing every time. With the English language, if I can take a paragraph and you can translate it into equations, and I change a couple words, now all of a sudden it's different, right? So you have to read very carefully. You have to be a good reader, for one thing. You have to, and that doesn't mean if you can't do this that you're a bad reader, but there's a bunch of skills that go into being able to do the contextual problems. You have to be pretty good at reading. You have to be able to understand what you're reading. You have to be able to think about it and go, okay, what does this mean? How is this like the problems I've done before? And there's definitely a critical thinking component. So we can definitely go over those. I'm totally happy to do that. The unfortunate news is there's no like golden rule I can give you that makes it all easy. It's just you kind of have to force yourself to become a better critical thinker, a better reader, and that kind of stuff along the way. But yeah, we'll go over those next time. We could do that for sure. Okay. Oh, right. Maybe I misunderstood the question. There was a question. Yeah, and we'll see about the 3 variables. I'll double check. I'll see how good the videos are that are in Delta Math because I don't remember. If they do it as good as I can do it, then I'll probably just leave you to those videos. But if there's any questions on the 3 variables, we can talk about those. But they do come up at some point. I suspect their videos are probably as good as what I can do. But we'll definitely talk about the context for stuff. Okay, so the idea behind elimination is that we're actually going to add 2 equations together and try to eliminate a variable. This seems weird. This, like, if you think about it, this is actually a big step from anything we've done before. And you go, wait a minute, we're taking 2 equations and adding equations together? Like, before we've taken terms and added terms together, and inside of equations we might add or subtract things. But now I'm actually going to take 2 different equations and add them together. What justifies that? What makes that okay? Like, how do I know I can do that? And sometimes students will ask that question. It's an excellent question, and the answer is you just have to trust me for now, because it's one of those questions that you can't really prove why that's okay until you get into linear algebra. Linear algebra is a class you take after calculus. So those of you who are calculus bound and are going to take the whole calculus series, and then once you get through it, you're going to take linear algebra and differential equations. So that is you that are mathematicians, engineers, certain types of scientists have to take all those courses. You'll end up taking a course in linear algebra that proves why it's okay to add equations together, like I'm about to show you. For now, you can just you're going to have to trust me a little bit and go, well, I guess it makes sense if the left sides equal the right sides. When we add them together, the left side should still equal the right side, right? So intuitively it makes sense, but if you're wondering why that's a legitimate move, it's an extremely complicated question to answer. But what we're hoping to do, we don't want to just take any 2 equations that were handed and add them together, because then we're just going to get some new equation, and now we've got another equation, right? What we want to do is add them together in a way where variables are going to cancel. If you remember, when we did substitution, the whole point when we substituted was to go to having 1 equation in 1 variable, because we know how to solve those. If I just have x's in an equation, I know how to solve that. If I just have y's in an equation, I know how to solve that. It's when there's x's and y's where all of a sudden we get like an infinite number of solutions, right? So that's our goal here. Add these together in a way where one of the variables is going to cancel. Well, if you're looking closely, this problem was set up in order to do that automatically. Look, in this equation, I have a plus 3y. In this equation, I have a minus 3y. So when I add them together, those y's are gone. They've totally canceled each other out, right? So like in this one, like the step 1 that we're usually going to have to do, which is a little more complicated, that's already done for us. I'll do an example in a minute where we have to go through that so that you can see how that works. But for now, I'm going to say, all right, let's add these together. Let's see, is this going to work if I do this? Oh, never mind. That didn't format like I wanted it to. We'll just put this here. So this is my third line. So step 1, I'm going to write the step that we're skipping because it was already done for us, but I just want you to see what that step would do. So what we would do is we would multiply equations by values that make a variable cancel. And that might not make a lot of sense at the moment. But like I say, I'll do one in a second where we have to do this step 1. But step 1's already done for us because I have the plus 3y and the minus 3y. I go, great, those are going to cancel. Let's move on. Step 2. Step 2 is we add the equations together. Technically, you could subtract, but we always generally think of them as adding them together. So what does that look like? Well, if I have 5x plus 2x, I get 7x. And then the plus 3y and the minus 3y cancel. That was the whole point. Equals, then on the right side, we have 2 minus 16, which is negative 14. So see how that went to one equation and one variable? In fact, it went there pretty quick, right? So when for this first problem, you might go, man, this elimination method is super easy. Because like, look, we already got to this equation, which most of you can probably do in your head, but that's because we got to skip the hard part. We get to skip the part that's actually a little challenging. Some people like substitution method more. Some people like elimination method more. It doesn't really matter. You should be picking the one that's best for the particular problem that you're working on. Okay? So hopefully we can all see that this becomes x equals negative 2. Okay? Once we know that x equals negative 2, now the good news is from this part on, once you've solved for one variable, the rest of our work in this problem is exactly like we did for substitution. These two methods only differ in the beginning. The end is the same. So remember what we did for substitution. Once we found one variable, we plugged it into one of the original equations and solved for the other one. That's all I'm going to do right here. So this will become 5 times, so I'm taking the first equation, the 5x plus 3y equals 2. So 5 times negative 2, which is our value for x, plus 3y equals 2. And when I solve this, I'll have my answer. So this is going to be what? That means negative 10 plus 3y equals 2. So adding 10 to both sides, I get 3y equals 12. So y equals 4. Oops, let me put a line break in here. So remember, for a solution to a system of equations, you need two values. You need two coordinates. You need an x value and you need a y value, assuming those are the two variables we're using, which 95% of the time will be. So you need two values, the x value and the y value. We got them both. How do I know I got them right? Remember, you have to go back and plug them in. Okay. So I think this is right. Let's just see. So if we go, so that would be negative 10 plus 12 is 2. Yep. And negative 4 minus 12 is negative 16. Right. So you probably want to write it out when you're checking these, but just for the sake of time, I'd rather skip that. But that's how you do systems of equations. We just did it, right? Okay, let's do one where that tricky step wasn't done for us, because I know that's the part that actually confuses students. So let's do one like that. Right. One thing to be aware of, I talked about avoiding fractions. You can sometimes, by not using substitutions, avoid some fractions, but you can't always avoid fractions. Sometimes there's going to be fractions in the problem. Sometimes there'll be fractions in your solution. So in that case, you obviously can't avoid them if they're in the solution. However, we can avoid them as long as possible by being smart, right? Working smarter, not harder. Okay, let's do this one. And then we'll probably be roughly out of time at that point. Let's see. So one thing you might notice here, we have A's and B's instead of X's and Y's. Who cares? It's not like, don't get hung up on it. It doesn't matter. They're just, the variables this time are A's and B's. Sometimes they're X's and Y's. Just depends what you're working on. Make sure I wrote them correctly. Again, I always recommend when you write a problem down, especially with these, double check you wrote it out correctly, because that's like half the time that a student is like, I know I did this right. I've checked it a bunch of times. And then we look and they wrote it down wrong right from the start. So don't do that, because that's a little demoralizing when you realize you just basically made it really hard on yourself. Okay, so remember before in the last problem, we had a plus 3y and a minus 3y, so it was pretty obvious what we wanted to cancel. It's like, we'll just cancel the ones that are ready to cancel. Here it's a little different. I have to look at this and figure out, well, do I want the A's to cancel or the B's to cancel? Which one do I want to do there? And it doesn't matter. Either way is going to work fine. There's not even, like, some people might argue that eliminating the A variable would be a little bit less work, which it would be slightly less work. I'm going to eliminate the B variable so that you can actually see, like, the worst case scenario, so that you can see, like, oh, that's how we do it in that case. Okay. So what we're going to do here is we're going to use the rule. Remember our rule from linear equations that says we can multiply the entire equation by the same value, and that's legitimate. It's okay to do that. So I could multiply the entire equation 1 by 2 if I wanted, and I could multiply the entire equation 2 by 3 if I wanted, right? Sometimes students think you have to multiply both equations by the same thing. If we multiply both equations by the same number, it won't ever get any better. We'll always be in the same position. We won't actually gain any ground. So remember, you're going to pick one value to multiply equation 1 by and a different value to multiply equation 2 by. Okay, not the same one. A different value is what you're going to multiply by. But you're going to multiply by something that's going to make them cancel. So those of you who are familiar with this or have done it before or just are picking it up very quickly, you might see, oh, why don't we multiply the second equation by -3 and get these A's to cancel? That's actually the cleanest way to do this problem. I'm not going to do it that way because I want to show you the full steps for like the longest possible way to do these problems, so that when you do problems where you have to do that, you'll know what to do. So I'm going to eliminate the B values. So I look at it and say, okay, I've got a 5b and a -4b. So how could I get those to cancel? Well, basically you want the least common multiple of those coefficients. What is the smallest number that 5 and 4 both multiply into? Okay, well, the answer would be 20, right? 20 is the smallest number that 5 divides into evenly and 4 divides into evenly. So, and look here, we have the signs are opposite. You always need the signs to be opposite, because that way when you add them together, they cancel out. Some people try to get the signs the same, but if you add 20y to 20y, you now have 40y, not 0y. So make sure your signs are opposite of each other. That's why down here, if you were trying to eliminate the A values, you'd probably multiply down here by negative 3a, so you'd have a 9a and a negative 9a, right? But we're doing the b's, so luckily the signs are already opposite. So then you just go, well, what do I have to multiply to get them to be that least common multiple? Well, the top equation I'm going to have to multiply by 4 to get a 20b, and the bottom equation I'm going to multiply by 5 to get a negative 20b. Right, so let me make a note here. Let's go, let me multiply it, and then I'll see if I can fit a note in afterwards. Let me see how I can format this. So let's go. Let's see, if I multiply by 4, this will become 36a plus 20b equals, so let's see, 16 times what? 4 is 64, should be 64. So what did I do here? I multiplied by 4 to get that one. So I took equation 1, multiplied it by 4 to get this. Okay, now we're going to multiply the second equation by 5. And this one I multiplied by 5. What's the problem? Okay, so there's what I did. I took this first equation, I multiplied by 4 to get this. Took the second equation, multiplied by 5 to get this. Let me make sure I did that right. Looks right. Okay. Notice how now we go, oh, there's my 20b and my negative 20b. Why don't we add those together? So let's do that. So when I add my a's, I'm going to get what? 51a. My b's completely cancel. That was the whole point. And what? 34. So you can see here we got that fraction coming up that I talked about. Sometimes you get fractions in your answer. Not much you can do about it. If your solution has a fraction in it, what are you going to do? You just got to figure it out, right? So this would become a equals the fraction 34/51, which I believe is 2/3. If you divide a 17 out of the top and bottom, you should get 2/3, I think. Yep, a is 2/3. If it recompiles here. Okay, so a came out to be 34/51, which I reduced down to 2/3. Always reduce those fractions. No reason not to. Okay. Now all we do is we go in and we have to plug a back in and get the other values. So notice this was that first step where I had to multiply both equations by something to get the variable to cancel. But notice that with elimination method, like this is your hard step, is figuring out what to multiply your equations by and then doing that. But once you do it, notice how you get a pretty simple equation to deal with right here. Remember when we did substitution and we substituted that expression into some bigger equation, and then you had some really big equation that you had to like simplify down? So with substitution, that's where the work comes in, is simplifying that big equation. Here, it's figuring out what to multiply your equations by. But the rest of the problem is pretty straightforward. So let's see. If I do that, let's take the second equation. So if I do 3 times the fraction 2/3 minus 4b equals -6. So I took equation 2 and from the very beginning of the problem, and I substituted in my value of 2/3 into it. Why is it not recompiling anymore? Let me see. Okay, so I just took equation 2, I plugged in 2/3. 3 times 2/3 gives me 1. No, it gives me 2, sorry. So 2 minus 4b equals -6. So it looks like when we go through subtract 2, divide by -4, we're going to get b equals 2, I think. Yep, b equals 2. So then we have our a value and our b value. We can double check them by plugging them into the original equations and verify that they work, and everything's good. So, and remember, the second half of this method is the same as the substitution. So it's just the beginning, just the first half of how you do these problems is the difference between elimination and substitution. If one of your variables has a 1 or -1 coefficient, probably go with substitution. If it doesn't, like this, probably go with elimination. But at the end of the day, it's not really that big a deal. Okay, is there any questions? Okay, I'm going to shut down the YouTube stream. Anyone who wants to talk to me in Zoom is welcome to do so. Otherwise, I will see you in a couple of days. All right, thanks, everybody.